So, good morning, everyone. Good morning, good evening, everyone. Good afternoon, everyone. And welcome to today's lecture. This is Capacitor lecture number 3, and we are supposed to start what? Types of capacitors. In the previous class, if you remember, we had dealt with what do you mean by a capacitor and capacitance of a capacitor. Do we remember this? A capacitor is nothing but a combination of two conductors. One of the conductors is given a positive charge known as positive plate. The other conductor is given a negative charge called the negative plate. Then we have the potential difference between the two plates, which is known as the potential of the capacitor, and Q, the charge on the capacitor, which is the charge on the positive plate, is equal to C into V. And we had seen the energy stored in the capacitor is half CV square. Do we remember this? Yes or no?
Yes, sir.
And we had seen that there
Yes,
are
sir.
three types of capacitor. Only one type of capacitor, which is a parallel plate capacitor, is in your course. Parallel plate capacitor, spherical capacitor, and cylindrical capacitor. In any case, we will try to cover them all. And let us start with the class for today. And in today's class, what we are going to do is understand capacitor, a parallel plate capacitor. So write the heading parallel plate capacitor. What do you mean by a parallel plate capacitor? Any idea? Anyone? Anyone knows a parallel plate capacitor? Anyone has heard about a parallel plate capacitor? What does a parallel plate capacitor mean? Parallel plate capacitor. The meaning of this parallel plate capacitor is hidden in the name itself. So a parallel plate capacitor basically consists of two plates which are placed parallel to each other. One of the plates is given a charge plus Q and the other plate is given a charge minus Q. Okay? One of the plates is given charge plus Q, the other plate is given a charge minus Q. How do we give this capacitor the charge plus Q and minus Q? We actually connect it to a battery. We connect it to a battery, and that is how we give the capacitor a charge. One of the plates is given positive charge, one of the plate is given negative charge. If you just want to see how it is connected, I'll show you with a diagram here. This is how you connect it to a battery. Everyone understands a battery, yes or no? Battery has a positive terminal, battery has a negative terminal. So I connect it with a battery. The side or the plate which is connected to the positive terminal, as you can see, gets a positive charge, and the plate that is connected to the negative terminal gets negative charge. Do we understand this? Yes or no? No, yes. Okay. So that is how you charge a capacitor. One plate is known as the positive plate and the other plate is known as the negative plate. Let me call the area of these plates. Both the plate have the same area. Let me call this area of the plate as A. Then we must remember these small points. Point number one, The capacitance of this capacitor is given by this formula, epsilon naught A by D. The derivation is not that important for us. What is important for us is to find out the capacitance of this capacitor, and the capacitance of this capacitor is epsilon naught A by D. As you can see, this capacitance C, what is the point that you must note here? That this capacitance C is directly proportional to area. This capacitance C is inversely proportional to the distance, and it is directly proportional to epsilon naught, which is the medium. Now this is the question, this is the answer when capacitor is not filled with any medium. It is having vacuum or air between the two plates. So therefore, we have epsilon naught A by V, epsilon naught A by D. Do we understand this? Yes or no? Okay. Now, if the potential difference between the plates is given as V, this V is the potential difference between the plates. Now remember, we can write different formulas here. If the potential difference is given as V, the charge on the capacitor Q can be written as C into V. Do we understand this? So you can write this as epsilon naught A by D multiplied by V. So you can write the charge on the capacitor in this form also if V is known to you. The more the number of forms in which you can remember it, beta, the better it is going to be for you. So in terms of charge, Q and potential difference V, this is the formula. Now I can write this formula in a different way. I can write this formula as V, potential difference will be Q into D by epsilon naught into A. Do we understand this? Why I've written this? How I've written this? Do we understand how I've written this, bacha?
Yes, sir.
Yes, sir.
Okay. Now you look at this Q and look at this A. Q by A is charge per unit area. So you can also write this V as sigma by epsilon naught multiplied by D. You can also write this potential difference as sigma by epsilon naught multiplied by D. Now, if you have to find out the electric field between the two, the electric field between the two will be V by D. So it becomes sigma by epsilon naught. Sigma by epsilon naught. Sigma is your surface charge density. So you can also write the electric field Q by A epsilon naught. Now, if you can remember all these forms together, that is going to be a very good thing. I'll give you 2 minutes to note everything down. Now, these are the formulas when air or vacuum is in between the plates. Now, if I fill this capacitor, the space between this capacitor with some other medium. So this green thing is that medium. And what I have done here is I have filled the capacitor completely with a medium whose dielectric constant is K. Do you understand dielectric constant? We have gone through this dielectric constant before also, yes or no? So now I have filled this completely with a medium of dielectric constant K. If I do that, then the new capacitance Ck with the dielectric constant becomes epsilon naught into K into A by D, or you can write it as K times C. So the capacitance, when the capacitor is completely filled up with a dielectric medium of dielectric constant K, it becomes K times C by epsilon naught. Do we understand this? Okay, so you need to note this down as well. Whenever a capacitor is filled with a dielectric of dielectric constant K, then the capacitance becomes K times the original capacitance. Have you noted it down? Okay, the next type of capacitor which you should just remember the formula is known as a spherical capacitor. Spherical capacitor. So write the heading spherical capacitor. And how does a spherical capacitor look like? It looks like this. It consists of two concentric shells, the inner shell of radius R1 and outer shell of radius R2. The inner shell is given a positive charge plus Q, and the outer shell is given an equal negative charge minus Q. As you can see in the diagram. Now, if I find the capacitance of this capacitor, and you will have to remember this formula, the capacitance of this spherical capacitor is 4 pi epsilon naught R1 R2 divide. I'll give you 2 minutes to draw this there. So this was spherical capacitor. You must remember the formula for spherical capacitor. The next type of capacitor is known as the cylindrical capacitor. So it basically consists of two cylinders, one above the other, two cylinders, one above the other, one having internal radius A or R1 and one having external radius B or R2. The capacitance of this capacitor is given by this formula 2 pi epsilon naught L divided by natural log of outer radius B by inner radius A. You can draw it in this way, or if you want I can show you the bigger diagram. Doesn't matter, you just have to understand that it consists of two cylinders. You can call the inner radius as R1 or R2, doesn't matter. I hope you understand this. Yes or no? So draw this diagram. I'll give you 2 minutes to draw it. And the next point is sometimes you might not have plate parallel to each other. Sometimes you may have one plate like this and the other plate like this. In that case, remember we are looking at the area which is getting overlapped. You can see the area of the plates which is getting overlapped. That is the area that we consider for calculating the capacitance of the capacitor. Do we understand this? So in this case, the capacitance of capacitor will be epsilon naught into whatever area that is getting overlapped. Do we understand this? If the complete area is getting overlapped, you will find out the complete area. If only a part of the area is getting overlapped, this area A that we use in this formula is the overlapping area. How much area is getting overlapped? So remember this point. Give you a 1 minute to note this down. We have understood that capacitance depends on the overlapping area. Now comes a question for you. This is a question and I'll give you 2 minutes to solve this. A very simple question based on the simple concept. 2 minutes, give me the answer fast. So how are we supposed to do this? We have just read one formula, beta. If you can't use that formula, then that is very difficult. Epsilon naught A by D. Here I have changed the distance. So I call one capacitance as epsilon naught A by D1. And I will call the capacitance in second case as epsilon naught A by D2. And I will in this divide. It is inversely proportional to distance. Is it so difficult, beta, that you can't understand this? You're just sitting for 15 minutes and doing nothing, beta. That will be equal to D2 by D1. Distance becomes half. So capacitance will become 2 times. The answer is 20 microfarad. That is the answer, beta. Please note it down. I'll give you 2 minutes to note it down. So this is the next question. Can I have the answer for this one, beta? Yes, beta, what is the answer for this one? The energy stored in a capacitor. What is the formula, beta? Anyone remembers it? No one? Okay. The formula is Q square by 2C. That is the energy of the capacitor. So please remember this formula, beta. Note this down. Let me move on to the next question. Are we ready for the next question? Yes or no? Great. This is the next question and I'll give you 2 minutes to solve this. Condenser means capacitor. Capacity is 50 microfarad. Charge to 10 volts. What is the energy? I hope you can get this answer. Anyone can tell me how you're going to do this? Capacitance is given and voltage is given. How are you going to do this, bacha? Anyone knows this?
Half CV square.
Yes, energy is half CV square. I'll give you 1 more minute. Put the formula and get the answer, beta. So well done. That is the answer. Congratulations to everyone who got the answer. Option A, half C into V square is what you had to do. I hope you were able to do this. This is the next one. I hope you can do this one as well. Simple formula you have to remember and simple question you have to do. This is the next one, question number 4. A parallel plate capacitor has a capacitance of 50 microfarad in air and 110 microfarad when immersed in an oil. What is the dielectric constant of the oil? You'll have 2 minutes to do this. How are you supposed to do this question, bacha? Question number 4. So remember, when we dip it in a dielectric, the capacitance with the dielectric becomes K times the original capacitance. Yes or no? The
Yes.
new capacitance is 110. that will be equal to K multiplied by 50. So you can get K as 110 divided by 50, and your answer would be 2.20. Do we understand this? Yes or no?
Yes, sir.
Yes, sir.
Great, 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 great. Let us now move on to the next question. This is the next question. Can I have the answer for this one? The capacity of a parallel plate, capacitor, or condenser depends on the type of the metal, thickness of the plates, potential, or the separation of the plates. What is the answer? On which factor does it depend on?
B.
Option B.
Option B.
Option D. Everyone understands this? Yes or no?
Yes, sir.
Well done. Okay, now we are gathering some speed to solve this one. Yes. The next question. The capacity of a parallel plate capacitor is C is capacitance when the separation between them is half. Yes. If the distance between them is half, then what will happen? Yes, my dear friends. What is the answer? Distance is halved. What will happen to the capacitance? And the answer is, we've done this question before. The capacitance will become 2 times. Capacitance, as you know, is inversely proportional to the distance. Yes or no? Capacitance is epsilon naught A by D. If your epsilon and A are same, capacitance is inversely proportional to D. So if D becomes half, capacitance will become 2 times. Yes or no? No, yes.
Yes, sir.
Why you have to take so much of time to do this question? I don't understand. Anyways, here comes the next one. I have to do 2 more questions to wind up this class. Yes. What is the answer for this one? When air in the capacitor is replaced by a medium of dielectric constant, what happens? Yes, my dear friend, what is the answer? Yes, my dear friend, what is the answer for this one? Don't have to think too much. It increases K times. Capacitance becomes K times the original value. I have given you the formula also. I hope you understand this. Everyone understands this?
Yes,
I am
sir.
not getting answer as quickly as expected. Next question. The next one, the last one in this category, the capacity of a parallel plate capacitor increases with what?
Option C, sir.
Option C, sir. That is exactly correct, sir. It is directly proportional to its area, so will increase with increase in an area. Do we understand this?
Yes, sir.
Okay. This is it for today. For today's class, we have done very good questions on parallel plate capacitor. We'll do some more questions on it. I'll give you time for today so that you can go back home and practice the questions on capacitance. You should remember the formula of capacitance, epsilon naught A by D, energy of the capacitance, half Q square by 2C or half CV square. We'll do more questions in the next class. Okay? Take care.
Yes, sir.
Please revise the formula of capacitance, write them together, revise them. Okay? Bye-bye.
Bye, sir.